Hello, welcome back to QuickMathics. I'm sorry for the late, for starting late. I had to stay back after school and I could make it a time, but here we are. We're starting a new batch today. Quadrilaterals and logic. A lot of info, but it's kind of fun. So let's get to it. Number one, given that this figure is a parallelogram, what is the value of s? Okay, since it is a parallelogram, this side will be parallel to this side, and this side will be parallel to this side. And I hope you guys like last video or last topic, I explained the different kind of angles. If these two lines are parallel, then these angles are conjugate, these are corresponding, these are alternate, and the different varieties. So in this case, I have this side parallel, this other side parallel, and I can say this is the secant line. So we have this angle and this angle. They are conjugate. So if they are conjugate, that means that they add up to 180 degrees. Other way to remember is that the adjacent angles of a parallelogram add up to 100 degrees. That's like a property of the parallelograms itself. But I just wanted like to recap the last topic so you guys like can have an idea. So now that we know that, we can just need to add them together. So 2s plus 30 plus 3s plus 50 equal 180 degrees. Now, 2s plus 3s is 5s, and 30 plus 50 is 80. So this equals 180 degrees. Now we subtract 80 from both sides, we get that 5s equal 100. And now 100 divided by 5 is 20, so s equal 20. This is our answer right here. Now let's continue. Given parallelogram, find the value of x. Okay, now in this case we're gonna use this theorem right here, but we can use the property of the parallelograms. So in the parallelograms, as I say, this angle and this angle add up to 100 degrees, the adjacent one. Now the opposite one, this and this, and then this and this, they are equal. So the opposite angles of parallelogram are equal. So if they are equal, I can say that 2x plus 10 equal 3x minus 15. Or vice versa, so it's easier to work with it. So now I'm going to subtract 2x from both sides and add 15. So this cancels out and this cancels out, and I get 3x minus 2x is equal x. And then 10 plus 15 is 25. That's the value of x. Now, in this case, given the parallelogram GHJK, find the value of a and b. Now, first of all, let's see a. Now, for a parallelogram, you know that the opposite angles are equal. The opposite sides are also equal. So the opposite are not only parallel but equal. So if these two are equal, I can say that 5a minus 9 equal 3a plus 5. So I'm going to subtract 3a from both sides, add 9. So this cancels out, and 5 minus 3 is 2a equal, let me just read back. 2a equal 5 plus 14 is 5 for 9 is 14, and then we divide by 2 and get a equal 7. So we go here. I would say this is not the answer. This is not the answer since a is equal 7. Now let's see b. Better. Now I say that the opposite sides are equal, so I can say that 3b is equal to b plus 84 because they're opposite angles. Now, what I'm going to do is subtract b from both sides, and this cancels out, and I get 3 minus b. 3b minus b is 2b equal 84, and then if I divide by 2, I get that b is equal 42. So this is not my answer, and this finished being the right one. Okay. Now, given parallelogram PQRS below, set all the true statements. So first they're asking for x, so let's solve for x. Now, okay, there the value of x is the value of this. Okay. One of the properties of a parallelogram is that the diagonals are the midcent the bisector, like bisect each other. Okay, that's the word I was looking for. The diagonals bisect each other. So if the diagonals bisect each other, this means this is equal to this, and this is equal to this. Now, basically there are ways to solve this. I'm going to show you one of my my favorite ones. So I have, if there are two, these two are equal, I have 2y minus 1 is equal to 2x. And then I have 2y plus 3 equal 3x plus 2. 3x plus 2. Now, put this in top. As you can see here, oops, I don't know why. As you can see here, both of them have the same y. 2y, 2y, but different x. So what I'm gonna do, I want to cancel the y. So I'm going to take this whole equation and subtract it from the upper one. So I'm going to say 2y minus 2y is 0. 3 minus minus 1, same sign. So it finishes being a plus. So 3 plus 1 is 4. Equal 2x minus 2x, x. And then 2 minus 1 is 1 positive. And we got that 0 plus 4 is x plus 1. Now, I'm going to subtract 1 from both sides. And I get that x equal 3. Now we have a value for x, which is not the value they say here. So this is wrong. Now that I have the value for x, I can say again to x plus 1 equal to y minus 1. Answer to for x. So 2 times 3 plus 1 equal to y minus 1. 6 plus 1, 2 times 3 is 6. 6 plus 1 is 7. So 7 equal to y minus 1. I'm going to add 1 to both sides. Oops. This cancels out, and I have 2y equal 8. And then if I divide by 2, I have y equal 4. Therefore, this is also incorrect. Now let's see. They're asking for QS. Oh, this is a tricky one because you can see that QS is the whole line. And they are giving us the equation for this part of the line and the equation of the other part. So we need to add up the two values together. So if we solve for this one, 2y plus 3, it's going to be y is 4, so 2 times 4 plus 3, it will be 8 plus 3 it will be 11. So this one is 11. But it's only this little side, qt. Now we solve it for this one here. 3x plus 2, so 3x is 3, so 3. 4 times 3 plus 2 is equal, 3 times 3, 9 plus 2 is obviously equal 11 because these two are equal. And now if I'm looking for QS, I need to add the two parts. So 11 plus 11 equal 22. And I can see here, QS equal 22. And this is not a right answer. Now let's see PR. PR, okay, it's the same. So it's asking for the whole thing. So I can substitute here. I can say 2 times 4 because y is 4 minus 1. So it will be 8 minus 1. So it's 7. This is 7. I know they need to be equal, so I know this one is 7. But in case, you can say 2 times 3 plus 1. 6 plus 1, 7. So say, and if we're looking for PR, is 7 plus 7, which is 14. And yep, that's the right answer. Let's see. In parallelogram ABCD, okay, AC is equal to DB. Okay, I don't have the parallelogram here, but let's draw it because I don't have it and I need to visualize it first. Okay, this is a normal parallelogram, the one we can see anywhere. And it is A, B, C, D. And we have AC and we have DB. Now it's saying that AC is equal to DB. So this side equal to this side. Therefore, like I know since it is a parallelogram, this equal to this. And if these two are equal, this means that this is equal to this. They four are going to be equal. Why? Because, this one is equal to this one. And then we're going to, like, they're going to bisect each other. So they're going to divide each other in half. If we divide two values that are the same in half, for example, the AC is equal 8, and if we divide it in half, then this will be 4 and this will be 4. And since DV is also equal A and we divide it in half, the part is also going to be equal 4. So the little parts are equal to each other. Now, we have that angle ABC, so ABC, this whole angle here equal to 2xy. And angle MBC, so no, BCD, I'm so sorry, BCD equal 9x plus 9. So 9x plus 9. Find the value of y. Now, this is something that you actually need to know the properties for. There's no way you can do it without knowing very well the properties. And I'm coming back in one. Okay, this is something that I draw before, and this is basically the properties for a square, rectangle, parallelogram, a rhombus or diamond, like just because we have it. Now, parallel like lines, like the opposite sides are parallel, yes, for the four. Now, the angles are equal to each other in the square. All of them are equal in the equal sides. I'm so sorry. This is equal sides. Okay, the sides are equal to each other in the square. All the sides are equal in the rectangle. The opposite sides. That's the this more or less for me. For me, that's my way to interpret it. I interpreted it. Okay, so more or less only the opposite sides. In the parallelogram, more or less only the opposite sides. And in the rhombus, yes, all are equal. Now, perpendicular sides, yes, yes, no, and no. Equal diagonals. So the diagonals, the measure of the diagonal, this is the figure. So this is one diagonal, this is the other diagonal. So the measure of the diagonal is the same. Yes in the square, yes in the rectangle, none parallelogram, none in the rhombus. Now, the diagonals are perpendicular. In the square, yes. In the rhombus, yes. In the rectangle, no. And in the parallelogram, no. Now, what I wanted to say with this is that you can see in the one of the property, like the property of the parallelogram, do not establish that the diagonals are equal. While in the property of the rectangles, they say that they are equal. So based on that the rectangle have all the properties that the parallelogram has, for example, these are the only two properties that I have here in the table. There are more, but that I have here in the table that actually the parallelogram have. Also, the opposite angles are equal, but in the square as well, in the rectangle as well. The adjacent angles are at 180 degrees that also happen in the rectangle. So I can say that if the diagonals are equal, then it is a rectangle because that is one of the properties of the rectangles, and all of the properties of the parallelogram are also fulfilled in the rectangle properties. So this is what I wanted to get to. So based on that, we can prove that the figure they are giving us is also a rectangle, and we can use the rectangle properties. So let's go back. So we are back. I just established that this is also a rectangle, so better I must draw it like this. So this is also a rectangle. A, B, C, D. A, B, C, D. We are looking for, this is 2xy, and this right here is 9x plus 9. I'm going to find y. Now to find y, we first next to find x because they're multiplying each other. So if we know this is a rectangle, this is gonna be a right angle. It's gonna be 90 degrees. So we can say that 9x plus 9 is going to be equal to 90 degrees. Oops. Now we subtract 9, we get that 9x equal 81 because we subtract 9 from each side. And then we divide by 9 and we get that x equal 9. And now we have the value for x. So we can say that 2xy equal also 90 because that's the value of the angles of a rectangle. And we have the value for x, so 2 times 9 y equal 90, 18y equal 90, and we divide by 18, and y equal 5. If you have any doubt, you go to your calculator, you divide it, you get the answer. Yep, that's our answer. So it is option B. Let's keep going. So what values of A and B make quadrilateral M and OP a parallelogram? So as we established before, a parallelogram has the opposite sides equal. So I'm sorry about that. So this side is equal to this side, and this one is equal to this one. Now let's do this. Ooh, this is like the one I showed you before. So we have for A plus B equal 21. Now we have 3A minus 2B equal 13. Now, as you can see, neither of them cancels out, but what we can do is we can multiply this whole equation by 2. If we multiply this whole equation by 2, we get 8A plus 2B equal 42 because 2 times 4A is 8A, 2 times B is 2B, and 2 times 21 is 42. Now that we have that, we can get rid of this. Ding. And let's go to a place we have more space. Now, as you can see, we can actually cancel out the B. So if we add this together, this whole equation, we add them together, we get 3A plus 8A is 11A. Now, negative 2 plus 2B, negative 2B plus 2B, they just cancel out. So plus 0 equal 13 plus 42 is 55. So we have 11a equal 55. If we divide both sides by 11, we get that a equal 5. So let's get to it. Okay, this is the only one that says a equal 5, but let's make sure that's true. Now, let's solve for b. Let's use for a plus b equal 21. Now we know that a is equal 5, so for times 5 plus b equal 21. 20 plus b equal 21. If we subtract 20 from both sides, we get that b equal 1. And we make sure the answer is right. Now let's continue. Given rectangle WXYZ below with WB 18. Wait. Find XC. Okay. Enter your answer in the box. Okay, this is just knowing the properties. As I said before, the diagonals of a rectangle are equal. And if the diagonals are equal and beside each other, so this one is equal to this one, and this one is equal to this one, vice versa, like they are all equal to each other, and we're looking for XZ, we know that this side is going to be 18 because this one is 18. And that's the property. Also, this side is equal to 18 because they must be equal to each other. And now if we're looking to the whole one, we just need to add them together. So 18. So 18 is whoa, what I did? 36. So a plus a is 16. We get 1. 1 plus 1, 2 plus 1, 36. Yep, that's the answer. Now let's keep going. So given rectangle QRST, we measure of the angle PTS. So PTS therefore is already in the figure, and QS equal 10. So QS equal 10. The whole line equal 10. Now, set all the true statements. So first they're asking for measure of QTR. QTR. Now it is a rectangle. And you're looking for this. I'm just gonna put a random variable. So x. It is a rectangle. We are looking for it for this angle right here, and we know this whole angle is 94. It's 90. I don't know what is the 94. It's 90 because it is a rectangle, so it has right angles. So I can say that x of measure of QTR plus 34 equal 90. Wait. So I subtract 34 from both sides. And I get x equal 56. So this angle right here is 56. Yep, here we are. Now, QRT. QRT. Now, we're looking for this angle right here. To do that, let me take away this, and I'm going to show you something that you might haven't like noticed. You know, this is a rectangle, so this side is parallel to this side. And now we have this diagonal right here. As you can see, as I explained in other videos, there is like a Z made here. And the angles in the Z, they are alternate angles. And if they are in the inside part, they are alternate interior. So these two are alternate interior angles. And the property for the alternate interior angles or the alternate angles in general is that they are equal to each other. So QRT is equal to 34. Now, let's see the measure of SRT. So SRT. We want this angle right here. So this is kind of the same. Like the difference is now we can either use, this is 34. We can use the 90, the same procedure we did right here, and we're gonna get 56. Or we can draw these two lines parallel to each other. We draw the second line. Oops. We know this is 56. They are also alternate interiors, so they are equal to each other. So this is not the answer. They are supposed to be 56. Now, QP equals 5. Well, we know that QS, the whole line, is 10, and that they divide in half. Like the diagonals divide each other in half. So if this is 10, 10 divided by 2 is 5. So this is 5 and this is 5. So yep, QP is 5. Now, RT equals 10. So RT is the whole line. And one of the properties that I explained before is that the diagonals of the rectangle are equal. So if QS is 10, RT is going to be 10 as well. Now, RP5, this is the same as before. We are dividing it in half, so this 5 and this 5 as well. So, yeah. The only one that is false or that is not true is the measure of SRT. Now, let's see this one. Given a rectangle DEFG below, select all the true statements. So, first they're asking for addition of x plus y, so we need to solve for x and we need to solve for y. Let's see what we can do. It is a rectangle, so as I explained before, all the like the diagonals are going to be equal on the segments as well. So if these two segments are equal, then 3x plus 2, oops, going to be equal 1.5x plus 8. So I subtract 2 from those sides. Oh wait, no, wait, yeah. Subtract 2, subtract 1.5x, subtract 1.5x, subtract 2. So this cancels here and this cancels here, and we get 1.5x. Okay, let me use a color. 1.5x equal a minus 2, 6. Now if we divide by 1.5x, oh, 1.5 both sides, I'm sorry, we get that x is going to be equal 4. Now if you can do it by calculator, so 6 divided by 1.5, that's 4. So we get that the value of x is 4, but now we need the value of y. Now, right now, we know that these two sides are equal. And for a triangle that has two sides that are equal, it means that it is an isosceles triangle. So this angle equal this angle. So I can call them both C. Let me call it C. So C. Now, based on the definition of the angles inside of a triangle, I know that then Z, the Z plus 120 equal 180, because the angles interior of a triangle, they're all, the addition of them is 180. So I can say that 2Z, this 2Z equal, I subtract 180 from both sides. Cancel 180 minus 120, 60. And then we divide by 2 and get the Z equal 30. So the measure of this angle right here is equal to 30, and this angle right here is equal to 30. Now, as I was explaining before, we have two parallel lines here. Wait, we have two parallel lines here. And we have a second line here. Now, this angle and this angle are alternate interior angles, just as the one before. And I can establish that they are both equal. So I can say that 2.5y plus 10 is equal to 30. So I subtract 10 from both sides. Cancel, so 2.5 y equal 20. Then I divide by 2.5. And if I'm not mistaken, y is equal 8. Let's make sure. 20 divided by 2.5 is 8. So y is equal 8. Now they're asking for x plus y. So it will be 4 plus 8. And it's going to be 12. So this one is right. Now they're saying that the age equals 14. So let's see. Um, we know that they are all equal, so we can add look for the value of this one. Actually, it's a lot easier to do. So I look for the value of this one. It's going to tell me the value of the other one. So 3 times x equals 4. So 3 times 4 plus 2 is going to be 12 plus 2 is going to be 14. So yeah, the age equals 14. Now measure the angle GDH. So GDH. So this angle right here. Now we know that this angle is equal to 30. And these two angles are 90 degrees because it's a rectangle. So I can say that this angle, I'm going to call it B. I don't know. So I can say that B plus 30 equal 90 degrees. Because this is supposed to be a right angle because it's a rectangle. And this is 30. So I subtract 30 from both sides and I get that B is equal to 60. So no, this is not right. Now let's see. Measure of angle FEH. So FEH, this angle right here. Basically the same. So this is okay. This is a process that is a lot longer, but I'm gonna just say it. So this in this one are equal. So this triangle is an equilateral triangle. Equilateral, no. I mean, if we know that two of them are equal, it's an isosceles triangle. I'm going ahead of myself. So it's an isosceles triangle. So the base angle is equal. So this one is also going to be 60 because we figured out the base equals 60. I'm going to keep the b. Now, as you can see, in this case, these two angles are also under the interior, so they're supposed to be equal. Therefore, this angle is also equal 60. And this is true. Now, FH, FHE equals 60. There's various ways to do it, but as I just said, like you know that these two angles are equal because they are this is an isosceles triangle. It's an isosceles triangle, you know. So the two base angles are equal. You're just missing this angle that I'm going to call A. So A plus 60 plus 60, 180. So A plus 120 equal 180. And I subtract 120 from both sides and I get A equals 60. And here we go. This is also true. I think that's all for today. I hope see you guys next week. Next week video should be longer, but you know we had like a lot done today. We did good. So let's see you guys next week. Don't forget to ask me anything in Discord.